Welcome everyone to today's Central 70 Colorado Covertop Best Practices and Lessons Learned webinar. Before we get started, we're going to give folks a couple minutes to join as we're right at the beginning of the hour. But we have some quick tips that we'd like to provide to you to get the best experience out of the webinar. So today we are recording this webinar and you will receive a copy of the recording along with the presentation files after the event. At the end of the webinar, Zoom is going to actually prompt you to take a feedback survey, and your responses are very much appreciated to help us improve our attendee experience for future webinars. Because we have placed everyone in listen-only mode, we do encourage you to please submit any questions through the Q&A panel in Zoom, and we have saved some time at the end to get to as many questions as possible. Now, before we get started, or as we get started, I'm going to pass it over to Adam Mercer, RS&H Senior Vice President and CDOT Construction Manager, to kick us off with the webinar.
Hey, thanks, Dana. Hello, everyone. I am Adam Mercer with RS&H. I've been with RS&H over 9 years and have a total years of 17 years experience. I lead RS&H's Central Region for our construction management business unit, and I have been involved with the Central 70 project since 2018, where I served as the construction manager. Dave?
Hi, everyone. My name is David Marenich. I've been the CDOT Quality Oversight Manager for the Central 70 project since 2016. I have about 14 years of highway engineering experience. I've been with CDOT for exactly 10 years, actually, this month. This is my second design build public-private partnership. My first one was on US 36 between Denver and Boulder. And through my career, I've realized that fostering a continuous improvement quality culture is really critical to the success of any major highway construction project. And I think we're going to be touching a lot on that throughout this presentation. So I look forward to sharing my experience with everybody here.
Hi, everybody. My name is Marshall Bailey. I have 8 years in the industry with RS&H. I've been on the project for the last 5 years since the very beginning, and my specialty was within tunnel systems as well as the covertop project manager.
Today, we're going to provide a brief project overview. We're going to discuss how the project affected the community and a few of the commitments we had to make. We're going to provide lessons learned for the cover systems and the cover top itself. And then we're going to close out with how the quality program was ran for this project. First, with the project overview. If you've traveled to Denver in the last 5 years, there's a high probability that you drove through our 12-mile project. This project was $1.2 billion and was a design, build, finance, operate, and maintain delivery method. It includes the section of I-70 that runs from the airport, DIA, all the way to downtown Denver. We broke this project into 3 main segments. The east segment, which was about 5 miles, was an interstate widening section. And we finished that one first. That was our first priority. That was where a lot of our traffic tied into 225 and Pena Boulevard going out to the airport. So we focused on that first. We finished that in 2019. The second segment was a full reconstruction segment. That's what we called our central segment. It was about 2.5 miles, a lot of overpasses, a lot of bridges, a lot of MSE walls, had to widen the footprint. And that was our heavy business zone, industrial. And then the last segment was the west segment, which is also the lowered portion. That included removing the interstate off the existing viaduct, lowering the interstate, and that was to be able to reconnect the community with some new at-grade crossing bridges. The viaduct was built in the early 1950s, roughly about 7,000 feet in this section in the west segment that we had to deal with. We were building right next to the Swansea School and the established neighborhood, which really butted right up against to the viaduct itself. So removing that was extremely hard when you're talking with 200,000 vehicles a day. We had to maintain that traffic. We had to maintain the access to the 1,200 businesses along the corridor. We also had to relocate 2 railroads and impacted a third one. Some of those project commitments I talked about was because we were so ingrained in the community and really went right through the community itself. One of those was air quality and noise monitoring. We had to do that live, minute by minute. We provided those monitors along the corridor, and we posted that real-time data so that the news agencies, the Department of Health, all those folks had our data, and they could see if we were exceeding our dust limits or we were creating an issue for the community. We wanted to be transparent in that. The next one was workforce development. Along the corridor, that 12 miles, we had a focused intent on hiring in the 7 zip codes that were impacted along the corridor. We had a $400,000 grant to support the local hires and do on-the-job training. This impacted 600 local workers and included 760,000 hours. The home improvements. So we had a 90% participation rate, and that was in the homes that were located right in the lowered section in that west segment. So 90% participation means 260 homes. We were able to upgrade a lot of the homes and a lot of their windows and things like that, that way it was safer for them for the long term during construction. So this program, we were able to swap out 870 windows, 755 storm windows, 145 HVACs, 140 doors, and we were also able to address 70 safety concerns that we found while they were in these homes making these upgrades. The Swansea Elementary School, because we were really right off the gate, we really impacted that school. We took this kids their soccer field away, so we knew we needed to do a lot up front to make this worth it for the community. So for they received $19 million worth of improvements. That included 2 early childhood education classrooms, a new HVAC system. It relocated the main entrance and a new school bus parking area. This project relocated 56 homes, 56 structures. So we had to have some affordable housing in this area. So we did a $2 million grant to the Affordable Housing Collaborative. Residents that were displaced received financial counseling and a potential access to financing through the Community Resources and Housing Development. And last, we had a partnership with the Northeast Transportation Connection Group. They provided incentives and to use carpooling and transit system. This is because of the construction in the neighborhood. We wanted to reduce as much traffic as we can. To date, we estimate over 1.2 million vehicle miles traveled were saved because of this program. So here's a picture of the west segment. You can really see on the left picture, the viaduct. This is us looking eastbound. So the first thing we did was we built the future westbound bore. You can see the bridges below the viaduct. They are at grade, right? This is where we reconnect with the community, as well as the cover in the background. As we progress construction, to be able to maintain that traffic flow and maintain the 200,000 vehicles a day, we took the traffic off the viaduct into the future westbound bore in a head-to-head configuration. This allowed us to demolish the viaduct over top of our new bridges that we had built and continue to build out that future eastbound lanes. Here's a few pictures of the viaduct demo itself. You can see exactly how close we are to traffic and how close we were to the community and in there. A lot of safety focus, right? Safety critical operations. We protected our structures underneath the demolition. That's where a lot of our focus was made. And again, you can kind of see the dust control and how important that was to make sure we were meeting those commitments. And next one is Marshall's going to start talking about this cover and the cover system. So as we build the park, we had to make sure that it was safe underneath there. So Marshall, if you can, go ahead and give us a rundown on the cover systems.
Great. Thanks, Adam. So just to orient ourselves on the project, as you can kind of see where those surface street tie-ins were to that cover top deck. And we have a north wall, a center pier, as well as a south wall. So this area made up the 1.5 mile lowered section. So that was made up of 1,800 drilled shafts, roughly 80 feet in length. And what we're going to kind of focus on is going to be those cover systems, just like Adam had talked about. And all of our cover systems actually are within our 16 16.6 clearance envelope. So everything will fall above that dotted line as we progress through the slides. So here is just another view. So like I was talking about previously, is our jet fan falls above that 16.6 clearance envelope. So this was one of our lowest elements within the cover. And then you can see some of our facing panels and barrier and what that lowered roadway section used to essentially looks like now, including where all of those systems and lights will hang underneath the soffit of the tunnel itself. And later in the presentation, as we can see, we have all those cover top elements, and Dave will be able to give us all the fun facts. So right here, we are looking at is the Cover Systems Denver Fire Screen. So when Denver Fire comes to react to an event, this is exactly what they're going to see. So they actually requested that we give them the minimum amount of information they're going to need to appropriately fight a fire. So essentially, this is just a stripped down version of what the operator is actually seeing. So the screen is actually located in 3 locations. So one is going to be in the CDOT command building, which is on the cover top, as well as the eastbound and westbound FCC rooms. So if Denver Fire does come to an event, they could react on the roadway at one of these FCC rooms. So essentially what this screen is telling us is that we have an LHD status. So the linear heat detection system is essentially our fire alarm in the cover. And this is a fiber optic cable that runs over the center line of each lane. So this is going to tell us exactly where that fire was detected if there was one to occur. And then tying into that is our deluge zone. So we have 10 deluge zones in each the westbound and eastbound bores. So as soon as a fire event would occur, that individual zone would actually light up to tell us exactly where that's at. So once that is detected, we do have cameras within the cover that will pan, tilt, zoom to the event. So the operator will be able to see it immediately by its home presets. So of these 3 cameras, the 2 outside cameras are pan, tilt, zoom cameras. And then we also have a thermal camera in the middle to be able to give Denver Fire the best possible information before they run into the event. And like I kind of said before, is we have that center pier and we do have some cross passage doors. So for some rhyme or reason, a pedestrian did have to leave their vehicle in the tunnel during a fire event, that they could cross to the other side of the board just to be able to escape that smoke. So as we get to the right-hand side is we have a deluge valve status. So currently everything is a stable state. So this valve is being shown as closed. So during an event, this valve will actually turn green to show that water is flowing in the tunnel. And then we have jet fans at both of the portal faces. So currently they're green, so they're currently off. And we have 18 total jet fans within the cover. So these would turn on individually until all 9 fans are on during an event. So these jet fans are not only utilized during a fire event, but also to manage air quality within the tunnel. So we do have some air quality readings at the top for either CO and NO2. So if traffic were to be stopped in there and the air quality starts to become poor, there's certain values that would be hit before some jet fans come on, so we can control that air quality within the tunnel. And now we're just going to turn up the heat a little bit. And as we can see, this is the operator screen. This is exactly what they were looking at. So this is just a little bit more information than the previous. And essentially, what is the operator going to do during a fire event? So the first thing that's going to happen is that deluge zone is going to turn red. And we have the banner at the top of the screen. So the operator can either acknowledge or abort the fire, depending on what they're seeing in those cameras. But just for the sake of this story, we're going to say that the operator is not actually at his desk. So during this event, this banner will actually flash for 60 seconds before all of these systems will turn on automatically without clicking any buttons. So when that happens, the tunnel is going to immediately shut down. So we have LUS or lane U signs at the front portals of each bore that will close down the tunnel. And then water will drop in exactly 2 zones. And like I had previously mentioned, is that the cameras will pan, tilt, zoom at the fire event. And at that same time, we're going to have all of these jet fans turn on individually until all 9 are on. But currently, since it's a test case, all of these fans are currently locked out. And while this is all happening, we also have speakers on the tunnel that will portray that emergency message, but we'll also have an AM/FM system that will take over your car radio and tell you the same exact message to either stay in your vehicle or to leave on foot. And we also have some wayfinding signage. So if you were to leave on foot, you could either go through the cross passage doors, or the wayfinding signage will light up in the direction away from the fire. So just a couple systems fun facts is we actually have 2,000 lights within the cover. So we have 1,000 each bore, and these are automatically controlled by a lighting control system. So all of the lights within the tunnel will actually automatically dim or brighten depending on the weather on the exterior sides of the tunnel. So your eyes just don't have that adjustment from the dark to a light space as you exit the tunnel. And we also had some very, very unique concrete in the bottom flange of the girders. And what essentially this is that in a normal tunnel situation, there's a 1 to 2 inch sacrificial concrete layer that is built to spall during a fire event. But with utilizing polypropylene fibers in the girder, it essentially just decreases that spalling. So we actually did a test panel down in Austin, Texas, and these are the pictures in the bottom right-hand corner. As we took a test panel and we put it in an oven for roughly 1 hour at 800 degrees. And as you can tell from the panel on the right, is there's very, very minimal spalling that occurred. And then also,
Marshall, I just wanted to chime in real quick. This picture in the upper right-hand corner. Earlier, you were talking about the 60-second countdown before the deluge event. The deluge system drops water on the roadway. Just a real life story that we actually had. A semi truck hits the outside barrier in this westbound bore, spilled some fuel, and the exhaust continued to run during that event. And the exhaust actually triggered the linear heat detector on that case. And so that started the 60-second countdown. Something that was a huge win on the project. The operators were well trained in this situation. They used the CCTV cameras, pan, tilt, zoomed into that event, saw there wasn't a fire, and aborted that deluge drop. So in your story, you were talking about what if no one's there, it will automatically start. But in this story, in this real life story, somebody was there and we were able to stop that from happening. Because obviously we do not want to drop water onto this road if we don't have to. So I just think that's a pretty cool real life story for everyone to know.
Yeah, and Marshall, if you can, just explain how big those jet fans really are.
So in that photo, the jet fans are actually 20 foot in length and 6 feet in diameter, and they roughly weigh about 8,000 pounds a piece. So they're going to be displacing roughly 80,000 cubic feet of air per minute. And as you can see from that little construction guy, I like the equivalent, just like how big these things actually are.
Yeah, and Marshall knows the cubic feet per minute, and I just know that it blew a chicken sandwich all the way through the tunnel while we were testing it. So I feel bad for the guy who missed out on his lunch that day, but it really gave me confidence that those jet fans are powerful enough to clear out smoke and air quality issues.
So now in this video is we're actually watching a testing scenario we had with Denver Fire. So as I kind of walked us through what a fire event looks like as far as on the Dynac screen, this is what it looks like in real life. And kind of another funny story is that linear heat detection system can also be tuned up and tuned down as far as sensitivity on what truly detects it. And that system would actually trigger during just like your standard paving operation. So you have your 300 degree grade, and then the roof of the tunnel would be so hot, it would actually trigger that linear heat detection system. But we had people that were watching the system, and we actually never ended up dropping water on these folks.
Marshall, that's not true either, is it? Didn't we have one incident that we dropped some water?
Talking about your manager throwing you under the bus. But so while we were actually testing the systems, we had a DINAC screen training to essentially train all the operators on what alarms come across and how to click through all the buttons to see the status of all the systems. But during that time, we actually never had a training platform set up. So during that time, we actually had to use the full-blown system screen. And little did we know, I mean, at least the instructor at the time didn't know that. So as we started to click through buttons, the systems were actually being triggered below. And at that time, I was actually instructed, to put that on record, instructed to click a deluge valve. And we actually dropped water, but we didn't know that at the time. All we heard was screaming upstairs and chaos and all those types of things. And we found out that we actually did get some of the crews wet down below. So that's a pretty funny experience. So by building all these systems in the cover structure, we had just like a laundry list of lessons learned, but just some of the high points is the RTM. So the RTM was a process that was utilized to track all of the contract requirements all the way through design, O&M, fabrication, install, startup, and commissioning. And with the amount of requirements there are so many multitude of ways that you can utilize as far as like a test script, checklist, test script, submittal, etc., to essentially prove out these requirements. And the requirements traceability matrix will ensure that each one of those requirements is satisfied at the appropriate time throughout a project's life. So we utilize this document the entire project. And also just kind of tying that in is also how important this commissioning process is that we have a startup and we have commissioning, but how it ties back to the RTM to ensure that all of our paperwork is going to be tracked and gathered at the right times, but also all of our teams are involved early in that process to ensure they know all the systems, how they're supposed to work, and how they're supposed to be integrated together. And another good story to tell is we actually utilized a pump station on our project. So that 1.8 mile lower section all flows to one point, and the lowest point is at this pump station area. So this water from the lower section is going to come in there and then be pumped out to make sure it's all dry. And we also have a separate drainage system strictly for all of the cover systems during a deluge event. So during a fire event, that deluge water would drop and come into this piping network and through a sand oil separator and ultimately to the FFS holding tank for haul off if there were any like environmental spills or hazmat spills that were included in that water. And Dave is going to give us a little additional input to another event that occurred.
Yeah, so that low point that Marshall was talking about is just west of the tunnel entrance. And August 7th, 2022, the Colorado had a 100-year storm event. And unfortunately, the pumps did not turn on to clear the water in our lower section and caused a significant amount of flooding where Denver Fire had to come out and do some rescues. And it was not the greatest day on the Central 70 project, I'll tell you that much. But first of all, thankfully nobody got hurt, and we really appreciate Denver Fire and all of the emergency responders for what they did that day. We immediately got started on trying to figure out what went wrong. We looked at the commissioning process and found that we commissioned this thing correctly. We tested it and it was functioning. Somewhere between during construction, somewhere between when it was initially commissioned and that event, the set points, so the computer activates the pumps at certain water levels. Those set points somehow got changed from the prescribed amounts. So that's what happened. The 4 large pumps there that you see in that picture, and the graphic on the bottom left corner, those 4 large pumps, which are meant to handle the heaviest storms, did not activate because the water levels were incorrect. So we have implemented a lot of improvements. As I said at the beginning, continuous improvement is what Central 70 is all about. We've added additional alarms to make sure that if people are getting into our cabinets, we know who they are. We've implemented additional alarms that get sent to the operators who are monitoring this pump station so that they know when pumps aren't turning on at certain levels and when pumps are deactivated. And then we also implemented a much more robust operation and maintenance inspection plan. So now every week we go in and we check those values. Is the set point correct? Is the pump going to turn on at the correct set point, like we had it originally commissioned to do? So that's another lesson learned. Commissioning is a very dynamic living process that needs to continuously, throughout the life of a project and throughout the life of maintenance, be looked at and verified.
Thanks, Dave. So now just kind of bring the commissioning process kind of full circle is just how important this is to ensure that it's appropriately defined within the contract. Is since the commissioning process is quality focused, even though the design of the system is going to be performance based, the commissioning process needs to be extremely prescriptive on what the expectations are. So those are just going to ultimately lead to higher quality and the higher cost savings. And what I kind of mentioned before is just getting the commissioning team's early involvement in the design and kind of bringing everything together, as well as the commissioning team and the quality team, ensuring that they understand how all these systems work, how they talk to each other, how each individual system works, but then also the integration part to bring them all together to ensure they work properly. And even by this graphic, is you can see that the cost savings, and a lot of people think it's very much can be financial, but also it takes a large amount of stress and anxiety of our folks to deliver these large projects. So by implementing the appropriate quality process, you're just going to minimize all of their headaches downstream. Especially when we're coming to close out like we are now, is extremely hard to go back and get the required paperwork you need to close out that RTM. So by implementing a solid quality program, including a commissioning process, will give you what you need.
All right, thanks, Marshall. So what's the point of putting these cover systems in? Well, it was so that we could build this park that you're looking at right now. So in the bottom left-hand corner, on the left-hand side, that is the Globeville community. And on the right-hand side, that is the Swansea community. And this park was meant to connect those two communities back. It's a 1,000-foot length, 4-acre park that we opened on December 3rd, 2022. It was a very special day for everybody on this project to be able to open up the park and watch people use the facilities and have a good time, and mariachi bands playing, and it was just a lot of fun. It's kind of the bottom left-hand corner I call reality, and then the upper left-hand corner, that's the dream. We're very close to the dream. I mean, all we have to do at this point is get these trees to start growing and thriving and develop a nice canopy. The ultimate goal for this cover top is to have a lot of shaded structure. This community historically just doesn't have a lot of trees, and this is one of the reasons why we made this park the way it is. So really excited that we are where we are today, but CDOT and RS&H and this team are going to continue to make sure that we establish these plants that we put up on the cover top for the next couple of years. It could be a long, drawn out process to make sure that that's fully established and the plants are thriving. So here's the same cross section that Marshall went through. I'm going to start on the east end here. So you'll notice that this bookend on the east is banked. The reason we banked the east bookend is if you're from Denver, you know, if you look to the east, it's boring and flat. If you look to the west, it's gorgeous with lots of mountains. Well, we banked this east bookend because we didn't want people to feel like they were on top of a highway. We wanted people to feel like they were on top of a park. And if you ever get a chance to come out here to this park and you get on the park and you look east, you don't see the highway. So this is really cool. A really cool feature that we designed in. The next thing I wanted to talk about is the lightweight fill. The lightweight fill, actually it's, if you move your pointer, yep, there you go. Lightweight fill is really important for the structure because that's the majority of the backfill that we put on top of the cover. And it is 65 pounds per cubic foot. It's a lightweight shale. A typical soil has 120 to 140 pounds per cubic foot. So we cut the loading in half by using this particular fill. Additionally, it's a very pervious material, which is something I'll talk about later about why that's important. So we reduced the loading on the cover, and then we also put in stout 10,000 PSI girders. These box girders are 10,000 PSI. A typical girder for a standard bridge at CDOT is usually lowest end 4,500 PSI and higher, probably about 6,000. So we doubled the capacity as well. So it's a very robust design and something that we're very confident won't have any long-term structural issues associated with it. So the biggest challenge of this cover top, looking at these cross sections, was the drainage. All the surface treatments are pervious materials, some more pervious than others. So all of the water that hits the surface is supposed to trickle down to the deck. On top of the deck, we have an asphaltic waterproofing membrane that is leak proof. On top of that asphaltic waterproofing, we have this drain board. So right above where it says waterproofing, I put in a picture of what our drain board looks like. It's basically a felt, it's got a felt top with these dimples in it. The water filters through the felt top and into the dimples, and that allows water to flow through where we need it to go. The deck is crowned. There is a 2% slope to the south in the middle and a 2% slope to the north. And then a 1% slope from the east to the west. So the intent of the drainage system is for all the water to permeate through the surface into this drain board, and then out to the edges. On the south edge and the north edge, we have a an edge drain that runs along the whole length of the cover, so that whole 1,000 feet. And then it ties into a storm system, and that clears the water off of our cover top. Another really cool feature about our drainage system, in the upper right-hand corner there, we got the moisture retention cups. So for the planted areas like these tree trenches, the grass, the real grass, and some of the plants, you don't want the water to go through too quickly. You want to be able to retain some of that moisture for a certain amount of time so that the plants can absorb the water and thrive. So these moisture retention cups slow down that process of the water getting through into that drain board. One thing I would say for any agencies looking to do a garden roof assembly, the most important thing to think about is drainage. And we'll talk a little bit more about that in our lessons learned later on. So here's just a quick overview of all the elements that we have. Like I said, the west bookend, that's the one that is not banked. That's where we have that viewing area, that concrete viewing area where people can take a break and look to the west and see our mountains. Next to that is Columbine Street. Columbine is the main pedestrian access to Swansea Elementary School. So we put wide sidewalks on both sides of the road. And one thing that I just find amazing is before we started this project, Columbine was there. And instead of walking over next to a park and a viewing area, they were walking underneath a viaduct that was falling apart. So I get a lot of pride out of seeing how much improvements we've made for Swansea Elementary School. And then just to the east of that, we have the multi-use synthetic turf soccer field. This is not real grass. If it was real grass, we would have a lot of irrigation issues and a lot of that water being retained in the real grass would have maybe overloaded that portion of the structure. So we went with this synthetic turf field. It's a regulation size soccer field. It's called the multi-use field because during school hours, Swansea Elementary School to the north of there has full access to the field. And then outside of school hours, Denver Parks and Recreation gets to utilize the field and program pickup games or practices or whatever they want to do. One thing to note about Swansea Elementary School is we did pay for the reconstruction of that school, reconstruction of the parking lot and the playground of that school. We didn't rebuild the school. The Central Plaza, that's where emergency vehicles, food trucks, and vendors come in. That's where during our opening event, we spent a lot of time in there. The CCD community building is the concession building, place for meetings, things like that. Just to the right of that is the CDOT systems building. That's our backup systems building. Like Marshall said, the main building is in CDOT Traffic Management Center in Golden. And then we have the amphitheater and the event lawn, and all the grass that you see in this area is real grass. And then to the right of that, we have Clayton Street. And one thing that I'm happy about, what we did a really good job on this project, is keeping Columbine or Clayton open throughout the entire school season. We could not close Columbine and Clayton at the same time because that would be major impact to the school. So keep your community happy. I think that's a big lesson learned. And then the east bookend, like I said, this is the banked bookend because nobody wants to look at the plains of Colorado. I mean, I guess
another good thing too, Dave, while you're on this cover, you cannot hear the interstate at all, right? So that east bookend and the west bookend really protect you from any of the interstate noise, which I thought was amazing when we were out there.
Yeah, that's a good point. Yeah, and that was not the case when the viaduct was looming. So I'm just going to go over quickly the lessons learned. This is just a quick overview. We're going to talk about each 5 of these lessons learned in more detail. So I'll pass it off to Marshall to talk about the 3D model.
Awesome. Thanks, Dave. So at least as you can tell, how complex the cover top is, the layering, the elements, the shapes, and making sure all those things come together. So as you can tell, the picture on the left was a 3D model that was actually taken of the cover top. And it's getting a little fuzzy because that 3D model was not drawn out past the cover approaches, essentially. So tying into all your surface streets, your sidewalks, and all the utilities around those areas became extremely difficult and complex. So from being on the project since the very beginning and going through the plan reviews and wishing we had a 3D model and going through those specs and just bringing everything together, how important a 3D model is going to be for our folks building them in the field. So it cannot be underestimated how important a 3D model is.
And it should be noted too, like I said, those alignments and all those finishings, you really need to make sure you're tight, right? We're not talking about a sidewalk on the side of an interstate or on the side of a road that's not tied to anything. So everything needs to be very precise so that it all kind of melds together. And that's something that we learned through our construction.
Compiled specifications. So as you can imagine, there's a lot of entities interested in this cover top. CDOT has their specs. Denver Parks and Recreation has their specifications. And what was important for us to do early on, before we started building this, was to sit in a room, discuss all of the specifications, all the inspection documentation, the frequencies, and figure out which of the entities' specs should rule. And so we developed a cover top inspection and testing plan. All agreed on it before the project was built. I think that really saved us from having a lot of arguments in the field. A lot of unnecessary meetings were avoided because we already knew which specifications we were using and what inspections needed to be done and what testing needed to be done. And a good example of that is the cover top irrigation. CDOT's irrigation specifications are wildly different than Denver Park and Recreation's specifications. Denver Park and Recreation is maintaining this cover top. And so it was pretty easy give from us to say, just build this per Denver Park and Recreation specs. So getting that out on the table before construction was a huge deal. There was also some CCD specifications that we needed to lay out. So that was a good thing. Garden roof assemblies, any entity or any agency that wants to do a garden roof assembly. I know the Clyde Warren Bridge in Texas is one. This is another, obviously. To me, just living this over the last year or two, the drainage is the biggest challenge of a cover top garden roof assembly. So in this picture on the left, you see this drain board that I was telling you about. The joints are not tied well together here. Just a lot of workmanship issues that we weren't happy with. And what was going on is the drain board installers would go in and just throw in a bunch of drain board, and nobody was ready to backfill it. So this drain board would be sitting out there for months, and people would be building walls on top of the drain board, and people would be walking all over it. The sun would hit it and it would ripple. And then it gets us to a point where we're looking at it and we're saying, you guys don't think you're going to put backfill on this, do you? We had to get them to take out all of the initial drain board that they put in, relay it, and then the next day they put the lightweight fill on over it. And that really saved us a lot of damage to that water board. And this water board is going to be buried under 3 feet of fill for the rest of the cover's life. We do not want to have to go in there and try to fix anything. So we had to get that right. So fortunately, we did get it right. Additionally, that South 46th Drive, which is on the south side, I was telling you about the trench drains that run to the west and drain the water off the park. Unfortunately, there was a design to put typical backfill on top of this roadway or below this roadway, directly on top of the drain board. So what ended up happening is the typical roadway constructors came in not knowing a thing about how this drainage system works, compacted the heck out of it like they're supposed to. This material had a lot of fines in it, and it ended up pinching off that ability for the water to flow into that trench drain. So we had to get them to remove it. We found it because we got a little lucky, and there was some rain that showed that the water wasn't draining the way we wanted to. We got them to rip it off, put in new material below the roadway, and then we tested it. And the big lesson learned here is we were able to get them to test it because we already showed it didn't work once. But having a proof of concept, a specification that has your contractor test out what was designed on these type of garden roof assemblies, I think is a big lesson learned for us.
Yeah, and that really brings us to this one here, and that's what Dave said, that proof of concept. And it also not just for the drainage and proving out the drainage design and making sure it works, just a proof of concept for all the aesthetics. We did have an aesthetic mock-up for the wall and the wall finishes, but really thinking through how tight that construction needs to be so everything lines up smoothly. We probably could have added some mock-ups, with the walls and with the retaining walls and where our pavers went to really make sure everything came together. But the big one was proving out that proof of concept for the drainage.
Yep, and operations and maintenance, that's another big lesson learned. We entered into a intergovernmental agreement, IGA, between Denver and CDOT before this developer was selected to build the project. It made it clear who was maintaining the cover park. Everything from the waterproofing up is Denver Park and Recreation. Everything from the waterproofing down is CDOT. And when I say CDOT, we've passed on our maintenance responsibilities through the P3 contract to Kiewit Meridian Partners. They're going to own, operate, and maintain the whole 10-mile stretch of this corridor for 30 years. They're going to do routine maintenance such as safety patrol, snow removal, operator presence at the CTMC. And then on top of that, they're going to do renewal work. So they'll be in charge of capital maintenance, mill and overlay projects, restriping, guardrail replacements, etc. And what really helped us lay that all out was O&M maps. When you're getting into a P3 project, maps are the best way to explain who's doing what.
All right, Dave, if you can, let's talk about our quality approach. We're coming up on a little over 45 minutes or so. So let's motor through this if we can.
Yeah, definitely. The quality approach here is there's two approaches that you can take on a design build project. We chose the second approach, which is using the contractor's ICQC, which is the equivalent of quality assurance. And the reason we did that is because we didn't want to influence the developer's schedule, and we didn't want to prevent the developer from taking ownership of the quality program. So by having the ICQC doing the QA testing and inspection, we stayed out of their schedule and we gave ownership to the developer who's going to be maintaining this for 30 years. This is just a quick overview of how that works. Quality control, also process control, also known as process control, is at the heart of that. Independent quality control, which is managed by the developer, is the secondary line of defense. And then the owner audits those two programs and makes sure that they're giving us a quality product and we have the final acceptance rights on that. And to do this, it's really important. There's hundreds of operations that could be going on at any given moment. And we needed to prioritize where we sent our folks for doing design audits, construction audits, and process audits. We used this assessment guide as our baseline. And I just like using this example. Curb and gutter construction, not a very high consequence. If something went wrong with the curb and gutter, it's visible, we can replace it via the punch list process. Also a very low likelihood. It's not the most complicated work in the world. On the flip side of that, let's say we're talking about caisson installation. That's the opposite. Early on, that was a high consequence and a high likelihood. So when we got into those high risk items, we audited those more frequently, and we sent our auditors to those operations more frequently.
Yeah, and we did that using their P6 schedule, right? This schedule on this project had 17, 18,000 activities. So we used an automated system that we created to, as they updated their P6 schedule monthly, it would tell us which planned audits we should create. So we use this risk matrix and our auditing software to actually be able to push this ahead. That way we knew where to send everybody.
Yep. And then from the results of the PC, IQC, and Oversight, we developed a tool to communicate with executive management. It's really important to get executive management support on the issues that are going on the project. So this is the tool we used. We look at our audits, we look at the IQC checklist, and we say, the MOT design or the material receiving reports aren't going well. So it starts off in the current issue. If it continues to be an issue, then it moves up into the ongoing issues, and we start putting flames next to the bullets, like we've got to figure this out quick. And talk to executive management on the project on a weekly basis. And one note that I want to talk about, asphalt pavement quality was an ongoing issue back in December of 2018. We received a CAPA award for best pavement on an industrial, I think on a rural setting, or not rural, an urban setting in 2021. So we went from it saying, and on our project, we have a major problem with asphalt quality, to receiving an award just 3 or 4 years later. So this process works as long as your executive management buys into it. And the better the pictures are, the easier it is for them to understand where the issues are, the better. So I put this in as a big lesson learned, to have a graphic like this that you can communicate effectively with your executive management.
All right, everyone, we finished up there. Really very thankful for you all joining us. And we do have some questions that have already been submitted. The very first one we're going to answer was from the beginning of the presentation. And Jack asked, what was the grant program for workforce development? And what were the funding sources for the community improvements, the school upgrades, home upgrades, and the affordable housing? So the first one, Jack, for the workforce development, we received that $400,000. It was from the FHWA. It was a Ladders of Opportunity grant that we used to fund that program. As far as the funding sources for the community improvements, that was actually built into the Central 70 budget from the beginning, because those commitments came through our environmental impact statement and our EIS that we had to meet to make sure we could deliver this project successfully. Anything else, guys, y'all want to add to that? No. All right. The next one, Jack asked, do you have a supplementary fire suppression system for chemical fires? And we did not, because this corridor was not for hazmat, if that's my understanding. Hazmats aren't allowed in this corridor. They actually, if you're coming into Denver, they have to take 270 up and around this location. But I will say one thing we didn't address on in the cover itself, on the far north abutment and the far south abutment, we have trench drains, as well as in the middle at the Pier 2, that are a separate system. So that way, if there's an accident and a fire in the cover section, and we go and we attack the fire, all that will go into the trench drains, which Marshall talked about, will actually be separated from our normal drainage and go into the fixed firefighting suppression system, pumped into the storage tank, 150,000 gallon tank, and held there until they can see if it has contaminants in it from the fire. And that was really the entire intent of those trench drains that are in the cover. The next one, Dave and Marshall, I'm going to have you all take this one. Jack asked, what was the lightweight fill developed specifically for was the lightweight fill developed specifically for this project, or is it a nationally available product?
This product is somewhat it belongs to Hydrotech, who is the company that helped us build this garden roof assembly. They build garden roof assemblies throughout the country, and it is a product that they get nationally sourced. So I think they have a couple of plants in Wyoming that do it, and there's a couple other out east that can make this for them. It's a crushed shale.
And Dave, was it built into the specifications up front, the Hydrotech system, or was it proprietary, or was it a Hydrotech system or equivalent in our contract?
It was a Hydrotech system or equivalent. We knew that Hydrotech could provide that, but if there was another company that could also provide that, they were welcome to. The developer was welcome to bring those people onto the project.
Okay, and we have one more question here. It was, who are the property owner of the park? Is it CDOT, local jurisdiction, nonprofit? And then is there an air rights or an easement agreement between those entities? And I think we answered that later on. So up into the waterproof layer, right? Or up into the waterproofing, that is all the concessionaire and CDOT to maintain. From the drainage board up is Denver Parks and Rec. And I do not believe we had to have an air rights agreement, correct, Dave?
No.
Okay.
That is still on CDOT right away, so there's going to be a perpetual easement that we allow Denver Parks and Rec in on that park to do the maintenance. So we own it technically, but Denver Parks and Rec maintains it.
All right, is there any other questions out there? All right, everyone, make sure we're cognizant of your all's time. It looks like we're finishing up early here for you all. If there's any question that comes up that we didn't answer or we did not address, please reach out to us. And I know, Jack, you were definitely the best question asker of the group. So if you have anything else, please reach out. We're available, and we will answer any question you have. And there's a lot more lessons learned, right? If there was a mistake out here, we probably made it, but we fixed it, and now our project's going to be better for it. So please let us know if y'all have anything, and please reach out. And Dave, man, thank you so much for joining us here for our webinar. Just from a consultant to a client, we really appreciate you, and this is the type of working relationship that we strive for on every job, right? So thank you so much for everything you've done for the last 5 years.
Right back at you guys. Could not have done this without RS&H. The expertise that you guys bring in really helped us set us up for success. So right back at you.
All right, Dana, if we can, we'll hand it over to you.
Awesome. Thanks, guys. You did a great job. Yes, we will be sending the presentation as well as a recording of today's presentation and another resource to everybody who attended. Thank you all so much. As Adam mentioned, if you have any questions, please don't hesitate to reach out. And have a great rest of your day.